Hey everyone, I hope we are live. Let me just check it out. Okay, I guess we are live. All right. Folks, can you just confirm if you are able to hear me properly? You can just say, yeah, I'm clearly audible so that we can get started with today's session. Okay, we just have few folks joining us today, but it's completely fine. All right. So what we'll do is I'll start with today's session. Mainly, we will focus on why it is very important to evaluate your retrieval augmented generation pipeline. And if you're not been following with the ongoing series that I'm doing, I'm just experimenting out with few advanced RAG techniques like how you can use hybrid search using Qdrant's miniCOIL. And then why is this experimentation very important? When you build any ML or deep learning based models, right? You use one algorithm, and after you use any algorithm, you run evals. So this evals is nothing but you check accuracy, you check precision, you check recall, and once you get a score, if it is lower, you try with different approach, right? So this is why I've started with this series where we start with simple RAG, and once we start with simple RAG, we experiment with hybrid search. Then we have a technique called hide, then re-ranking. So once we have these approaches, we evaluate, and based on the results, if it is not working fine, we go with one approach, right? So here in today's session, mainly we will focus on what are the best techniques we have to utilize when it comes to building evals. And there is very nice article which is written by Hamel, that is on LLM Judge, and I'll also walk you through what is this LLM Judge and what are the ways you need to use in order to build your own evals, right? So I'll quickly get started with today's demo. But before I dive into today's demo, here are some quick starter points that one needs to remember. If you want to build evaluation pipeline for RAG pipeline, the first thing is you need to have a data set against which you can evaluate. Even when it comes to machine learning, right? You have training data set, you have testing data set. Once you train your model, you evaluate it on testing data set and you get a evaluation report, and based on that you experiment with different algorithms. So this is where having a data set is very important. Now when I say having a data set is important, you might have some questions. Hey, how should I what should this data contain and how should you build it? So when it comes to what the data needs to content, the major thing is scenarios, right? When it comes to RAG pipeline, there might be chances that you might have just single response from the database, right? So you have medical related chatbot. So for medical related chatbot, you're saving a medical report within your knowledge base. So now you might have one based on the user question, you might have single answer. Now for the same question, you might also have multiple answer from different pages. And there is also chance that someone who is using your platform, he will not even ask any question related to database. He will ask something out of context. So you also have something related to no answer, then invalid data provided. So when you are building a data set, you just have to keep one thing in mind, have different scenarios within your data set, right? If it is related to medical policies or medical documents, just make sure when you are creating the synthetic data, you have different scenarios. And then you should also have different personas. So this different personas is nothing but in what kind of questions you are supposed to generate. Is it related to expert, and are the questions related to technical folks, or is it related to non-technical folks? So when you are building your own data set, you just have to ensure that you have different scenarios and you have different personas. Now that you have some understanding of okay how my data needs to look like, the next possible question is how do I generate this data set? It's very simple. You can generate your entire synthetic data set using LLMs, and you can use very light LLMs like you can use GPT-4 or Mini, or you can also try using Grok, or you can use Samba Nova. So from Samba Nova, you can use Llama 4, or you can use DeepSeek R1. So you can use this kind of LLMs when it comes to generating synthetic data set, and how much data set you need, that that probably is something that you can't predict. So my assumption is you can have somewhere around 40 to 60 questions within your synthetic data. And now, one more thing you have to keep in mind is when it comes to generating synthetic data set, you're supposed to give a prompt. Once you give the prompt, you generate the data set. In this prompt, you have to clearly mention that the data set has to be diverse so that it can cover most of the edge cases. Because, as I said, right, you need different scenarios, you need different personas. So, you need to have a data set which is diverse. So, make sure you include this keyword, very important. I'll just add it as double star so that this keyword is included within your prompt when you're generating the synthetic data set. All right. Now that we know some understanding of, okay, we know what the data needs to look like. We know how to build the data set using LLM plus prompt. The next thing is, this is where some bit of understanding is very important. Whenever you are building a RAG pipeline, you need to have someone as a domain expert. This domain expert can be the client with whom you are working with, or it can be someone on the senior role who understands what the data is, what are the keywords which is very important within your data set or within your own knowledge base. What is this domain expert supposed to do? Let me tell you this. When I showed you this diagram, right, like LLM eval dashboard, you might have seen these keywords like 4, then 4.9, 4.5, 4.9, then 3.5, 3.7. So why are these numbers very useful or not useful, right? So whenever you are building any evals, you might have seen people saying that, hey, you got this response, rank this response between 1 to 10, which is completely wrong. Now, when you tell LLM, what is difference between 8, 9, and 10? Let's suppose you ask a question related to what is black hole, and you get the response. Now you just have to tell LLM to rank this response. LLM to rank this response based on the accuracy. Okay, let me get this to the next line. Now you have the accuracy score as 8. Now what is this 8 justifying? And if it gives 9, what is this 9 even justifying? When it comes to ranking based scoring, it's not justifying any results. So this is where when it comes to labeling your data set, right? Let's suppose you generate the entire data set and then you have a domain expert. What this domain expert needs to do is it should just tell pass or fail instead of giving scores. So what I'm trying to get at is, instead of using scores, which is ranking based, you need to have scores which is in binary. Binary in the sense it should be true or false, or it can be pass or fail. Now, this is very easy when it comes to telling true or false, but the major thing where you need the domain expert help is to write the critics. So, when you have any question, you get the response which is pass or fail. But why is it pass? Why is it fail? This is where you need to have very concise and very accurate critics, which is very important. And this critics can be provided only by a domain expert. So, whenever you build a data set to evaluating your RAG pipeline, after you have the data set, just make sure it is labeled based on pass or fail, which is binary. And once it is binary based labeled, the next thing is you need to have a new column which is critic. So this critic is nothing but you need to have a domain expert who gives some information why it was pass and why it was fail. So this critic is later used for future prompting. So why is this future prompting important? I have mentioned few scores here, right? You have helpfulness, you have truthfulness, then accuracy. You have something called as LLM as a judge. So what LLM as a judge will do is you give a prompt. Based on this prompt, you will tell whether it is pass or fail. So you have LLM who is evaluating your responses. So when LLM is evaluating, what you can do is you can pass this critic as a few shot so that it understands very well when it has to do false or it should give true. And with this response, you should also get a feedback. So what this will look like is you have the user query, and once you have the user query, RAG will fetch you the context, and once you have the context, you are generating the response. And now what this LLM as a judge needs to do is it needs to tell whether it is true or false based on the given context, and then it should also give a feedback. So this feedback is nothing but the critic. So critic is very important whenever a domain expert is labeling the data. So now that we have the label data and as well as the LLM evaluation, what are the next steps that we are supposed to take? We have to trace and monitor our entire pipeline. So this is where today's video is very important, because we will build the RAG pipeline using hybrid search, and then we will also use Opik to trace and monitor our entire pipeline. So tracing and monitoring is very important in the production setup, so that once you have few user queries, you have a dashboard where you can see what kind of questions user are asking and what kind of response were generated and what is your eval score. Based on that, you can fix the obvious issue which has been occurred within your data set, right? So this is very important in order to fixing the obvious errors. This is very important step, and it's also very difficult step also, because not every time you know what kind of errors you're getting. Okay, so that's the reason why I've written as obvious errors instead of just errors, right? So tracing and monitoring is very important, so that you can look into what are the obvious errors and then later fix it. And in order to use this trace and monitor, we will use Comet Opik in today's session. And later, for the future purpose, if you look at the blog articles that I'm writing, I've already covered two blog articles. And in the third blog article, I'll be telling how you can optimize your prompts using DSPy library, where you can utilize prompt optimizer and signature. So this is the next thing what we will be doing in the ongoing series. So in today's video, we will mainly cover this thing, which is LLM as a judge and tracing and monitoring. And now let's just look at few of the evals that we will be utilizing. And in order to use RAG, the main focus will be on the user question. And based on this user question, we will extract the context. And from this question and context, you will generate the final response. So this is what you mean by retrieval augmented generation. And you have different evaluation metrics, which is context relevance, which is mainly is your context relevant to the user question. Then you have answer relevance, is your answer relevant to the user question. And then you have groundedness, which is your answer related to the context. And then you also have the retrieval techniques. This is retrieval evaluation, and whatever you have here is for the generation. So generation generates the answer, and evaluation, which is your retrieval evaluation, will generate your context. And here we have something called as precision and recall. If you have read machine learning, probably you might have come across what is precision and recall. It's very simple. You have a confusion matrix. So in confusion matrix, on your this axis you have real, which is nothing but action. Here you have predicted, and I'll just add some 1. This is 0, and here you have again 1, and then you have 0. Let me quickly check the diagram as well. Okay, we are good to go. And if it is 1, which is, let's suppose you have a model which predicted it as 1, and if your actual is also 1, this is what you call as true positive. And if your actual is 0, and if you are predicted as 1, it's nothing but your false negatives. And now if your actual is 1, but if you have predicted it as 0, this is nothing but your false positive. And now if your predicted is also 0, and if your actual is also 0, this is nothing but true negative. So this is how your confusion matrix will look like. You have true positive, then you have false negative, then you have false positive, and then you have true negatives. When it comes to precision, it's nothing but out of all the positive that you have predicted, how much was actually correct. So you just have to look at this particular thing, which is TP divided by, it's TP plus FP, and your recall is nothing but TP divided by TP plus FN. So this is the precision and recall, and we will utilize the same approach in the retrieval pipeline as well. Mainly retrieval pipeline will return the context. We just have to get the context and check was it relevant to the user question or not. So now that we have some basic understanding of how to evaluate using the own data set, then how to build one, then labeling it based on the binary judgment with critic. And then you need to have LLM as a judge, where you can trace and monitor, which will later help us to fix the obvious errors. And in order to trace and monitor, we will utilize Comet Opik. And in order to build the RAG pipeline, what we will do is we will utilize LangGraph. Let me just write today's tech stack. We will utilize LangGraph for the RAG pipeline, and we will use Qdrant for the hybrid search using dense vectors and sparse vectors. So these sparse vectors we will be using miniCOIL, and you can also utilize something called as BM25. And then we will use Comet for tracing and monitoring, and we will use Gemini for the LLM response. So this is the tech stack that we will be utilizing, and I already have the cookbooks for you. So what I'll do is I will just start with the installation step, and I will also share the cookbook for you so that you can follow along with me. I will just copy this link and let me attach it in the comment section. Hi home, will you keep the stream on the channel? Yes, this link will be active after the end of this session as well, so that you can watch it anytime. Hi Ahmed. Is this considered as agentic RAG? We are not using agentic RAG for this approach. We are mainly focused on hybrid search. But if we want to implement agentic RAG, we can use React agent with LangGraph component, which is something that can be configured. And if you are keen to learn that, you can keep following the blog series. If you have checked my blog series earlier, we have worked with agentic RAG. We will also release one article on agentic RAG, but this is mainly focused on hybrid search. I hope you got the notebooks. Okay, why not Langsmith? Langsmith is mainly used for tracing as well, tracing and evals. And since I've used a lot when it comes to Opik, I've found Opik to be very flexible, and also you can track any component. When it comes to Langsmith, it's only specific to your LangChain component. But when it comes to Opik, it is also configurable with any frameworks you use. And it's not just with the framework. Let's suppose in the same pipeline, you have evals, right? Let's suppose I'm using this recall, I'm using this precision, and I have context relevance. So here I'm using ragas. Let's suppose I'm using ragas for context, precision, and any evaluation metrics. And if I want to add the custom support to evaluate and trace this as well, I might need some support which is directly integrated with this. So this is where I can use Opik directly. If your entire tech stack is only specific to LangChain or LangGraph, then you can use Langsmith. But if you want to use different tech stacks within your own pipeline, then having Opik is very important. And again, Comet Opik, it's integratable with any integrations, whether you're using Llama Index, LangGraph, or if you just have a simple LLM. If you have a function which is only utilizing an LLM, you can directly use Opik instead of Langsmith. So that's the whole purpose of using Opik in this video instead of LangSmith, since we have Dragas as well. And I want to track my evals. Okay, so what we will do is we'll proceed with the code evals, the code demonstration. And after that, if you have any more questions, we'll be taking those. Probably let's get started since the installation is done. Now what you have to do is, I will click on runtime. And once I click on runtime, I will just click on restart session. And once I click on restart session, you have to configure your API keys. And in order to configure API keys, we need Opik, and we also need Google API key. I will also attach Google API key. And in order to get Google API key, you can use AI Studio, aistudio.google.com. Let me copy this URL. Get your Google API key. And once you click on aistudio.google.com, you can see the dashboard of Google AI Studio. And here you can select Get API Key. And then if you scroll down, you can find this API section. I'll just click on this and I will come back to Collab. And in Collab, you have something called as secrets. You can click on secrets. And here, what you can do is you can click on Add New Secret, paste Google API key, and then whatever key you have copied, you can paste it here. Since I've already have Google API key, what I will do is I'll just delete this. As I said, in the name column, you just have to give Google API key, and in the value, you just have to attach your API key, which you have got from aistudio.google.com. Okay, let me come back to Collab. I'll just attach it here so that you can get your API keys. And now that we have already added Google API key inside Collab secrets, the next thing is we need to get our Opik API key. So in order to get Opik API key, you can click on comet.com. This is the URL. Get your Opik API key. And here, what you can do is you can sign up with Google. And this is very important step. What you have to do is you have to notice two things over here. Once you sign up, there are two keys you need. The first thing is you need the workspace. So if you notice on the left hand side at the top, you have the workspace which is mentioned. If you have signed up via GitHub, you will have your username as a workspace. If you have signed up via Gmail, based on your Gmail ID, whatever you have your workspace. In my case, Tarunar Jain is the workspace, which is nothing but my own name. So I will just copy this and I will come back to the collab. And if you notice here, Opik workspace equals to Tarunar Jain, whatever my name is. And then what you can do is you can click on new project, and here you can give any name. I'll just give live session. And then what you can do is you can tell hybrid search RAG Evals. So you can give any name, you can give any description. Let's just make sure I'm not giving any hyphen. I'll just keep it as live session, which is single name. And then your project visibility should be public, and just create. Now you have your own live session, which is the project. You have your own workspace, which is nothing but Tarun Arjun. And now in order to get your API key, click on your profile icon. And here you will find something called as API key. Once you hover on this, you just have to copy this API key and come back to your collab. Again, create a new secret by Opik API key, which is the name, and then you can just attach your key. So now if you see, we have Google API key, we have Opik API key, and then you just have to attach your Opik workspace by your username or anything that you have configured, and your Opik project name will be evals. In my case, it is live session. I will just copy this live session and I will paste it here, and I'll just run this cell. And since you have added your keys for first time, it will just tell you, are you supposed to grant the access? I'll just tell grant access. Okay, so Opik API key, Opik workspace, then Opik project name, then Google API key. Google API key is from AI Studio. All right, now that we have set up our credentials, the next step is we need to start with our project. So here, what I'm doing is I'm building a customer service chatbot for Shopify. Okay, so since I'm building customer service chatbot for Shopify, I need to get some details from Shopify. So what I will do is there is something called as FAQ page, frequently asked question. So I will just open this URL. So if you see, you have some questions related to getting started with Shopify, you have selling on Shopify, then you have payments related to Shopify, and then the shipping details. So what I need my chatbot to do is, if any questions is asked from this website, I just need to answer it. And you can also attach multiple web pages and then save it in a vector DB. In this case, I'm just using the single web page and I'm pasting it here. Now, how do we build a RAG pipeline? Let me quickly show you that as well. Let me open the slides. Okay, I do have some slides related to RAG. Let me check if it is this one. Okay, I do have a slides related to RAG. So basically, if you want to build a RAG pipeline, the first thing is there are two approaches. One is the offline document processing and then the real-time user query. Let's start off with the offline document processing. Whenever it comes to offline document processing, it is just one-time approach where you're saving your data inside a knowledge base. So you can start off with any external data. In our case, our external data is a web page. In your case, it can be anything. Here I'm taking the example of YouTube video. Once you have your external data, the next step is you have to convert that into multiple chunks. Now, why is this chunking very important? Every single LLM model has a context window. And for Gemini, it is 2 million. Then for OpenAI, it is 128K. Claude, it is 200K. Then most of the open source LLMs has 32K, right? So it's very important to chunk your data so that you can just give relevant information as a context via prompt to your LLM. So get your external data, then chunk your data, and then convert that into embeddings so that you can save it in a vector DB. Now, why is it important to convert into embedding? So that you can get a semantic meaning out of it. So when I'm saving it in a vector DB, if you notice the arrow mark, I'm giving both chunk data and as well as the embeddings of it. So this is what you call as offline document processing, which is just 4 or 5 steps when it comes to LangChain. Now, when it comes to real-time user query, which is augmentation and generation, let's suppose I ask a user question. Now, this is happening on real time. Once you ask any user question, you have to use the same embedding model that you have used while document processing. So it will convert my user query into embeddings, then it will look into vector DB. And once it looks into the vector DB, it will return the search, right? It will return the search context, which is relevant to the user query. So this is the context which I'm passing it to the LLM. Now, if you look at the entire RAG pipeline, the LLM has two inputs. One is the query. Now, based on this query, whatever the relevant context is. So this is what I mentioned here. When it comes to RAG, you just have to focus on three things. One is the question, one is the context, and then the answer component. This context is been retrieved from vector DB, and then answer is being generated by a large language model. Now, if you notice, based on the user query, you have vector DB, which will do this schematic search, and based on the similarity search, it will generate the retrieved context, give it to the LLM. Now, LLM has both user query and the context, and it will generate the final response. So now let's build the document processing first. In order to build document processing, you need to have the loaders, which is nothing but web-based loader. Since my data is related to web page, and if you are using different loaders, if it is PDF, you can use from langchain community.document loaders import py-pdf loader. For YouTube, you'll have YouTube loaders, right? So based on your own data, use the relevant loaders. And then you have a recursive character text splitter, which is mainly used to chunk your data based on the token or chunk size. And then you have embedding. In order to convert the embeddings, what I'm doing here is I'm using something called as fast embed. Now, fast embed, there are two advantages of using it. Two advantages. So the first one is it runs in the Onyx runtime, which will load your model comparatively faster than normal open source LLMs. So mainly we are utilizing open source LLMs here. And it also provides data parallelism. And one more advantage, I'll not say advantage, but it also helps us to use both sparse and dense vectors. So let me just make it 3 instead of 2. And for sparse, you have BM25 or miniCOIL. And for dense vectors, you can use anything, whatever open source LLMs you have, right, on the leaderboard, MTB leaderboard. Mostly it will be BGE models, or you have Gina embeddings, or you can use something from Salesforce. But in our case, we will be using BGE models. And yeah, so this is the reason why I'm using fast embed embeddings. It is also open source. Now the next step is, since I said we'll be utilizing Qdrant as our vector database. We need both sparse and as well as dense vectors. So I'm utilizing fast embed sparse, which I've already mentioned. Here we'll be using miniCOIL, and then we'll be utilizing Qdrant vector stores to save our database. And since we are utilizing hybrid search, we have something called as retrieval mode, which is hybrid. And then we just have to initialize the Qdrant client. If you have used vector databases, you might have seen that there are different ways you can run vector db. When it comes to Qdrant, you can run it in three different ways. So the first way is you can use Qdrant cloud, which is cloud.qdrant.io, where you need the endpoint and as well as API key. So the second approach is you have to run locally using Docker, and third, it's in memory. So in memory is nothing but you create a local file within your project directory. Once you create that project directory, it's only within your project folder. You can't access it outside. Same when it comes to collab. Once the internet goes off or once you disconnect your runtime, your data is gone, right? So this is what you call as in-memory location. And for our approach, we'll be utilizing in-memory. But if you look at some of the blog articles that I've utilized, I've mainly used Qdrant Cloud, where you can get your endpoint and as well as API key. And if you're not sure of how to get the endpoint and API key, you can probably watch some of my videos related to Qdrant. I personally believe this video, which is customer service chatbot, is utilizing Qdrant Cloud. If not, you also have one more video, which is here, build your own MCP agent, where I'm using Qdrant. You can check out those videos to get the API keys. All right. So now, as I said, in this video, we'll utilize in-memory location. Let me run this now. Now, the first step is to get our external data, which is nothing but Shopify web page. If I print documents, you have your raw data. So if you notice, you have the raw data. I'll just get 0th index page content. So if you notice, all the information that you have within your web pages, it is extracted using page content. And you have one more field, which is called metadata. Metadata is very important. I'll tell you one reason why. Let me see if these slides have that information. Okay. Just 1 second. I want to show one of the case study from Uber. Okay, so there is one article by Uber where they have shared how they have built an enhanced agentic RAG. What if chatbots could deliver near human precision? And here in this case study, they have shared the entire architecture on how they have built their entire agentic RAG approach. Here, if you notice, here they are also utilizing hybrid search, where they have the vector search and they have BM25 search. And what I want to show you is here, if you notice the document processing part, once you use your knowledge base and extract the information, here they are creating the summaries of it. So you have the data, you're creating the summary of your data and saving it in a metadata so that you can use it for search. It's not just metadata, you have summary, you have frequently asked question. Using these two fields, you're giving more context so that you can get relevant chunk when you are doing user query. So this is what is very important. And when it comes to financial related data set, right, your metadata will have multiple documents. Let's suppose you have 10 documents. I ask a question, from which document the response was generated and from which page number. So the source and the page number is very important in the financial domain. And in the Uber case as well, what they've done is they've saved the summary and as well as frequently asked question. So this way you can improvise your entire RAG pipeline. In our case, we don't have page number because the data that I've used was a website. If you are using PDF, you will have source, you will have majorly you will have page number, and you will also have some created data as well. So these are some metadata which is already pre-built using LangChain. And in our case, I'll just use the existing ones. And once you have your external data, next thing is you have to chunk it. And when you chunk your data, you have to pass chunk size and chunk overlap. So chunk overlap is 0. I'll tell you what is chunk overlap 0. So if I print the length of documents, it is 1. Now if I print the length of chunks, it is 13. So what chunk overlap will do is, now let's suppose you have 13 chunk. In my chunk 2, do I need any information from chunk 1? If yes, then you can use some chunk overlap. If you don't need any overlapping between your chunks, which is your consecutive chunks, then you can keep it 0. If you need little bit of context, then you can define it as 150. Okay, so either it can be 150 or it can be 200. Just don't exceed more than 200 because you already have 1000 as your primary chunk plus 200. So that means you have total 1200 in a single chunk. And when you're doing the relevant context search, it will be into 4, right? So it's fine if you're giving any 200 or 300, but just make sure you just define it very less. All right. So now I'm just splitting the chunks as well. And in our case, we have total. Okay, why did the number change? Let me run this again. Okay, I changed my chunk overlap to 200, and that's the reason why it became 15. If I make it 0, it will be 13 again. Okay, this is fine. Now we need to use embeddings. And when it comes to embeddings, we need two embeddings. One is sparse and one more is dense. Now, what is the difference between sparse and dense? Mainly, sparse is non-fixed length. Okay, so when you convert your text into embeddings, you have a constant size, right? But when it comes to sparse, there is no fixed size. It will be in a variable size. And second, it will be either 0 or non-zero elements, non-zero values. Now, when it comes to dense, it is of fixed length. And it will be somewhere between 0 to 1, and it will be in decimal points. And it's not that you will get directly 0, you will have some decimal points, whether it is in minus or positive. And dense vectors are always in the fixed length. I'll show you some examples in the upcoming project code as well. So now you can define your sparse embeddings. In our case, it is miniCOIL. I don't want to give HF token. And if you notice Qdrant miniCOIL v1, this is the sparse embeddings that I'm utilizing. And for embeddings, I'm using fast embed embeddings, and the model name is BAAI BGE large. So as I said, you can utilize this model, or you can use something called as the NLPR GTE large. So this will load the model locally. So now we have these sparse embeddings and as well as dense embeddings. So it's usually 1 GB of model. Okay, so now that we have the embeddings, the next step is we have to define our vector store, which is Qdrant, and I want the retrieval mode to be hybrid. So what are the other retrieval mode that you can utilize? You can either utilize dense or you can utilize sparse. So sparse is mainly nothing but keyword search, keyword based search. And when it comes to dense, it's mainly vector based search, right? So you can utilize any one of them, either it is hybrid or dense or sparse. And now, as I mentioned, there are three ways you can utilize Qdrant vector, what you call three ways you can save the data inside Qdrant. One is cloud, second is locally using Docker, and third is in memory. When you're defining in memory, you just have to make sure that you're defining a path where you have to save it. In my case, the path is a temporary folder. Inside that, it has to create a new folder called eval app. If I just check the ls, let me just do ls temp. You have some data, but you don't have eval app. So if I just run eval app, as you can see, cannot access temp eval app, no such file or directory exists. So now what you can do is you can create that particular folder, and then inside that you can create a collection name called evals rag. Now collection name again is very important. Let's suppose you are working at some startup, you have initial data. Using this data, you built a chatbot. Now this data is getting changed and it's been updated, and you have to build the chatbot again. So that time what you can do is you can have initial v1, and once you have the updated data you can have initial v2. So this way you can keep the versioning of your data using the collection name, and you just have to ensure your collection name is unique, right? So what I'll do is I'll just keep it initial v1. And now what you have to do is you have to create collection. When you are creating collection, there are two things you have to keep in mind. If you are building a collection name for just simple RAG pipeline, you only have to define your vector configuration. This is the only thing you have to define. But if you are building a hybrid search, you have to define sparse vectors as well. So this is something that you have to keep in mind. For hybrid search, you need both vector and as well as sparse, which is nothing but vector search and keyword search. But if you are just using vector search and if you need simple RAG, you can only define vector configuration. And when you define this, as I said, it will use vector search. So you have to use something called as cosine similarity. And the size of the embedding is 1024. So here, if you notice this point, dense is a fixed length. That means all the embeddings that you convert, you have total 13 chunks. These 13 chunks will be converted into embeddings, which will be of size 1024 each. But whereas sparse will have different sizes, right? So this is something that you have to keep in mind. I'm defining the vector configuration by defining dense. This is the keyword, and vector params to be 1024 embedding dimension, and the search is nothing but cosine. And for sparse, I'm defining model sparse index params on disk to be false. So if you want to save your memory in RAM, you can keep on disk to be true. But since I'm not utilizing any cloud service, I'm just keeping on disk to be false. So now if I run on this, I have the collection set. As of now, you just created a space where you have to save the data, but you didn't included the data yet. You just have the space, right? So now what I will do is I will define my Qdrant vector store. Till now, you're just defining your client and you created a space where you can save the data. Now what we will do is we will dump the data. So when you dump the data, add your client name, add the collection name, and this is your dense embeddings. And here you have your sparse embeddings, and retrieval mode is hybrid. You can use dense, you can use sparse, you can use hybrid. I will go with hybrid search, and then you can define these two keywords. So if you notice here, vectors config is dense, sparse vectors is sparse. So just copy this keywords: dense, dense, sparse, and then sparse. Now you will have your vector store ready. You just have to save your chunk data. And here I'm creating some random UUIDs. So if you print UUIDs, you have some IDs. These are the unique identify tokens. So usually when you are building any vector databases, right, you have to define a payload. So for payload, you have to have a unique identity for your each data, right? So here you have total length of UUID. If you print, it should be 13. If you print the length of chunks, this is also 13. So what you're trying to do is you have the client of vector.db, you created the space. Now when you want to dump the data, add both chunk and as well as the ID so that you have certain identity for each chunk. So whenever you want to retrieve any chunk, and you can just identify based on the unique identity, which is nothing but UUIDs. So just add Qdrant.add documents, define your chunks as documents and IDs. So this is optional. If you want to add or if you want to extract the metadata along with IDs, this is where this is very important. If you don't want to extract the metadata, you can also remove this. This is also fine. If you run just documents equals to chunk, even this is completely fine. So now what this will do is it is adding our data inside the specific vector DB. Now if I do ls, so let me copy the same command. Earlier it showed no search file or directory. Now if I print this, it has a collection and as well as meta JSON file. If I look into the collection, I will have initial v1. If you see, you have initial v1. So this is where our data is saved. Now what we can do is we can use similarity search and get the information out of it. So now if I open the FNQ page again, just copy any question from your data. How do I need to start selling on Shopify? Here, just use Qdrant. Qdrant is nothing but the vector DB that you have defined. Then Qdrant.similarity search, add your user query and just search. If I do length of it, probably it should be 4. This should be 4. Yeah. So what is happening here is when you are saving, you have your user query. When you are using vector DB, you're doing search here. So this 3 is nothing but search. This relevant context, if you notice this, you have different relevant chunks. So this is 1, this is 2, and this is 3. But in our case, by default, k value is 4, right? So if I do the 0th index, then I need to get the page content. So there are just two fields. One is page content and one more is metadata. So here is where you have your original context. So this is just knowledge transfer. And you also have different chunks. Most of it are irrelevant because in our case, only one chunk will be relevant. So if you want to change that, you can do that as well. Here you can just define your k value. Let me check if k value is 2. And if I do the search now, length of it, this should be 2 now. So you can define how much length you need or how much relevant document you need. In our case, 4 is good enough. So I'll just keep the default ones. But as your data increases, you have to keep your k value to be 7 or 10, right? But since we have very limited data, 4 chunk is good enough. All right. So instead of similarity search, you also have one good search technique called MMR, which stands for maximum marginal relevancy. In our case, let's just use maximum marginal relevancy. And here, this is how it works. It's similar to how similarity search works, but this is more diverse, right? So now you have these two search techniques. Either use similarity search or you can use maximum marginal relevancy. Okay, so far what have we done? We built retrieval. So you have RAG, which stands for retrieval. Then you have augmentation, and then you have generation. So retrieval is already done. We saved our data into vector DB, and then we used MMR or similarity search to get the context. Now, when it comes to augmentation, here you just have to define a system prompt and instructions. So what augmentation is nothing but I ask a question. This question can be anything like what do I need to start selling on Shopify? What if I ask what is black hole? So black hole is not there within my data. So if you want to handle this, you have to augment your prompt saying, hey, if the user question is not from the context, just say I don't know, right? So you have to augment that. And in order to augment, it's better to always use system prompt. The best practices to define a system prompt. You can define the role play. Then you can define instructions, and then you can define certain motivation in negative sentiment. Let me show you one good example of this. I just want to search wind. And I'm pretty sure most of you might have heard of what Windsurf is. Windsurf is one of the IDE which helps you for code generation. So this is how their system prompt looks like. So if you see here, you are an expert coder who desperately needs money for your mother's cancer treatment. So what is happening here? You are an expert coder. This is nothing but a role play. So if you see here, in order to define a system prompt, define the role play, define instruction, then define motivation, but in a negative sentiment. So, expert coder is a role play. Your mother's cancer treatment, it's like you're giving 1 billion for a LLM model if it does any task. So, if I read this prompt completely, you will be given a coding task by the user. If you do a good job and accomplish the task fully while not making extraneous changes, Codium will pay you 1 billion. So you have the task, which is nothing but given the user prompt, you have to generate a coding task. So role play is an expert coder, instruction is coding task. This motivation is nothing but you're giving 1 billion parameter, 1 billion money, and this negative sentiment is nothing but you are only getting this 1 billion for a mother's cancer treatment. So this is nothing but a negative sentiment. Again, these are just experimentation technique. You can give motivation, whether it is positive sentiment or not. This doesn't matter, but it's good to use. And one of the technique what I usually use is, if you don't do this task, you're fired, right? This is also negative sentiment. You are doing certain task. If the task is not completed, you will be fired. This fired is nothing but, again, it's in a negative sentiment. So define the system prompt, define the instruction, and then generation is where you are using LLM, which is Gemini 2.5 Flash. So here you are giving query, you are giving context, and then generating the response. So let's quickly get to the final part of our code. I'm defining the Gemini LLM, and then I have LangGraph where I have the start node. Every single function, here you have two functions. One is search and one more is generate. And this will act as a node in the LangChain graph, LangGraph. Okay, and the next thing is I need to define the document so that whenever I'm extracting this text data, right? So if I print this, if you notice, this is a document format, document object. So this is the reason why I also have to define the LangChain core documents, so that once I have the text data, I can wrap that inside a LangChain document wrapper. And now if you notice here, I'm using Opik integration so that I can track the LangGraph approach as well. So from opik.integration.langchain, import Opik tracer so that I can track whatever is happening within my RAG pipeline. So this is the system prompt. You are an expert QA assistant who answers question using the only provided context as the source information. If the question is not provided, if the question is not from the provided context, just say I don't know, not enough information received. If the task is not performed, then you are fired. And then you have the human prompt. In this human template, what you have to do is you have to pass the context. This context is being fetched from your vector db, and then you also have one more input variable, which is nothing but user question. If you notice the diagram of RAG, there are two inputs which is going to LLM. One is the context and one more is the query. This is what you are defining within the human template. If you are building a chatbot and if you have memory, you can also define chat history over here. You can also define chat history, but in our case there is no memory, so I'm just removing this component. So now the augmentation is done, the retriever is done, the augmentation is done. Now we have generation. For generation, what we have to do is, I'm just utilizing Gemini 2.5 Flash. The temperature is 0 so that there is no randomness that I'm creating, and max tokens is none so that it can utilize as much as tokens possible. You're not restricting the model, so I'm just adding max tokens to be none. Now if you notice, your retriever is done, augmentation is done, generation is done. You just have to stitch that using a LangGraph graph component. So here I'm defining the state. In this state, I have question, have context, I have answer. Once I have this three information, if I come back to the board, I have the question, I have the context, I have the answer. So this is mainly used for RAG pipeline. Now, after this, what you have to do is you also need to evaluate. So for evaluation, I'm just using these two. One is context relevance and one more is answer relevance. And I've already mentioned, instead of using scores, use binary, which is true or false, right? So this is what we will be utilizing with an approach called LLM-as-a-Judge. So if I come back to the code, I'm defining my state. So all the variables that you want to track, one is the question, context, answer, context relevance, and answer relevance. These are the 5 things I want to trace and I want to track. So just run the state. Now define the node. So there will be total 4 nodes. First node is the search, from which you will get the context. Then you have generate, which is generating the final response. And then you have context relevance, which will take the context, which will take the question, and will also provide answer. And then we will evaluate it whether it is from the context or not. So this eval is nothing but LLM as a judge. So you just have to define a prompt and you have to define a LLM component. And then you have answer relevance. It's the same thing. I'll just copy this entire thing here, but the prompt is different. So these are the four nodes that I want to define. So the first node is the search. So I just have to get the relevant context, which is again very simple. Quadrant dot similarity search, define the user question, which is state question, and then generate the relevant context. So if you notice, everything is a dictionary. Whatever I am returning, it's a dictionary. So define your search. Now when it comes to generate, here if you notice, you are first fetching the relevant context. First retrieve the relevant context, and here I just need the page content. If you notice, let me show you how this works. I have context equals to quadrant similarity search, what is black hole. Now if I print this context, it has total 4 documents, but what I need is, I only need the page content. 0th index dot page content, you have the string. So what I want to do is, given the 4k value that I have, extract all the strings, combine them and pass it to the LLM. So this is what I'm doing. So it is currently in the document format, extract the string element and then pass it as a context to the LLM. Now you have the message. So if you see, you have the role, which is system prompt. Then you have role, which is nothing but the human prompt. In this human template, you have context and as well as query. So this query is directly tracked from your state management, and then you have context from which you're extracting only the string. So now if you just directly add LLM invoke, so if you want to use LLM, right, you can just use LLM.invoke what is black hole. So now if you see, I'm using an LLM. Here it will generate what is black hole. But when I ask RAG pipeline, it will tell I don't know. So I'll just show you this once we have the final response. So this is before RAG. So if you see, you have the content, a black hole is a region of space-time, blah, blah, blah. You got the response from LLM. Now I have the generate function. It's doing the same thing. I'm using LLM.invoke. I'm passing the user prompt, and then I'm returning a response, which is nothing but, again, a dictionary. So earlier, as you notice, where is that? Your search will return the context. Your generate will return the final response. It should be in dictionary. So now we have the answer and we also have context. So now we'll proceed with the final two nodes, which is nothing but context relevance and answer relevance. So you have a prompt, and in this prompt, whenever it comes to writing a prompts which has different instruction, you can define it in a XML format. So this is a criteria. And once you look at the criteria, you also have instruction. Same thing, what I'll do is I will also copy the same instructions and criteria for answer relevance as well. So once you have the prompt, get the relevant context. If you see, you have the context and then the facts as the relevant user question, and then directly define the prompt. In this prompt, you have to define the instruction and then define the eval setup. So this eval setup is nothing but you have your input variables. So if you see, facts colon relevant document, which is nothing but the context, then question, which is from the user. So this is what you call as context relevance C colon Q, that is the user question from the given context true, yes or no. So this is what we want to find, CQ. So this is where I'm defining the relevant context and the user question, and then system prompt is nothing but whatever I've defined here, and then directly use LLM invoke and return context relevance. Okay, now that we have context relevance, we have three node set. Now we are moving with the final node, which is answer relevance. So for answer relevance, if you notice, my eval setup has answer relevance, which is a quote q, which is my question relevant to the answer. So there is a nice blog article. There are only 6 RAG evals. So this is one article which is written by Jason Liu. And if you notice, we just have to focus on question, context, and answer. And context relevance is nothing but C and Q. And answer relevance is nothing but A and Q. This is what we have defined. Answer relevance is done. Then context relevance is done. You just have to define the prompt, define your input variables, and then pass it to your LLM. And LLM has to generate in a string. And when you return your node, it should be in dictionary. So far, we have 4 nodes. We have 4 nodes, which is search, which is generate, and then you have context relevance, and then you have answer relevance. Since you're using state management, you're storing all this. Now, what are we supposed to do? You have to define what is the linear flow, or you have to run it parallelly. So here, first approach should be, first I want to use search. Second, I want to use generate. So it's a sequential flow. Start with search, then go with generate. Now what you have to do is you have to run both context relevance and as well as answer relevance parallelly, right? So if you run in a sequential order, it will take too much of time. So your search will take 1 second, your generate will take 2 seconds, context relevance will take 2 seconds, answer relevance will take 2 seconds. But if you run parallelly, you're reducing at least 1 or 2 seconds for each user prompt, which is very useful, right? So third, you have to run parallel node for context relevance and answer relevance. Now, why am I saying it to be parallel node? Because look at the input variables. If you look at the input variables for answer context, you need question and you need answer. So from where are you getting the answer? You're getting answer from generate. If you look at the input variables for context relevance, you need question and then you need the relevant context you're getting from search. So you already have input variables from previous node. So now when it comes to context relevance and answer relevance, you can run them parallelly. So this is what LangGraph is very good enough to run flows in parallel mode. So let's define the route. So if you notice, route to parallel, I'm defining a state where define the node. So if you notice this, get answer relevance, it is a function, but in LangGraph this will be considered as node. Get answer relevance, get context relevance, I want to run it in parallel. So I just define a function called define route to parallel, give both the nodes, which is context relevance and answer relevance. And if you want to join the node again, just return a simple state, right? So I'm defining context relevance, I'm defining answer relevance. Then I want to join them again for the end result. So this is where I'm defining a empty state. All right. So now it's time to build the graph. Our graph will start with search, then it will go with generate. So we are adding 2 nodes. Then let's also add node which is context relevance and answer relevance. And then I'm defining an empty node. So here you're just adding all the nodes, right? First, just add all the nodes that you have. Now what you need to do is define the edges from where you have to start, from where you have to route. So first, after adding add edge, you have to define add edge, which are connecting the nodes, right? Here add edge is nothing but how do I connect? Start, first you start with search, then search to generate, which is nothing but I start, search, generate. It's a linear format. Then what I need to do is I need to add a conditional edge where you are running parallel nodes. Here just add your route parallel where you are defining both the nodes which needs to run in parallel. And once that is done, just add both the nodes to a joint node. So what this joint node will do is it will return an empty state. And if I run this and if I show you how the graph looks like, so you start, then you use search, and then you generate. And once you have generate, you can run answer relevance and context relevance in parallel. This is nothing but a conditional node. If you see, sorry, it's conditional edge, which is in dotted format. All right, and then you have the join node, which will generate both answer relevance and context relevance in parallel, and then you just end it. So this is how our entire graph looks like. This is how you can trace, monitor your both hybrid search RAG. All right, so this is the final step where we just have to run the user query, and track the evals on Opik. And if you want to track it, what you can do is you just have to add this as a callback manager. So Opik tracer equals to Opik tracer. Just add the graph that you got. Just run this. And now when you run the user query, just add graph.invoke, define a user prompt. Here, if you see config, add callbacks as Opik tracer. This is very important if you want to trace your LangGraph state. So just define config, callbacks Opik tracer. If I just run this, you will get your response. So if you see, Opik started logging traces to live session. Live session was my project name. If I click on this link now, so what was the user question? The user question is what happens when I receive an order. You have this question. If I click on this, it will tell how much second was taken for search, and it took only 0.2 seconds for search, then 0.8 seconds for generate. If you notice here, it is also telling what is the cost of it. If I click on chat Google generative AI, it will also tell me how much tokens was utilized. The more tokens you utilize, the more money you pay for your LLM cost. So this is where tracing and monitoring is very important. And then if you see, you have route to parallel, which is running 0 seconds. Then you have answer relevance. Then you have context relevance. And here, if you see, it's a binary, true. Then if I check on context relevance, it is true. That means my given user question is from the context, and whatever response is generated, it is matching with the user question, and it has to be binary. All right. So if you see, overall, it just took 4 seconds for both search and as well as evals. I'll come back, and if I just print the response, I have the response. You can print anything that you need. Response. Here you also have context. Sorry, question, which is the user question. Then you have context. So whatever you defined within your state, you can track that, which is answer, context, question, context relevance, and answer relevance. 5 things. And if I print this context relevance, you have true, and you also have reasoning, which is nothing but critique. And if I print answer relevance, you have true, and you also have explanation for it. Let's ask something which is out of the context, which is what is black hole. Earlier, if you see, when I asked what is black hole, it generated the response. Where was it? I did run LLM.invoke. Okay, so I just removed it. If I print what is black hole here, it will generate the results of the black hole. So let me just show you the response between that. Okay, we are also reaching the time limit. Okay, so if you see here, you have the content. A black hole is a region of space-time. You got the response. But here, if you look at the node, response to, if I print this response, I don't know, not enough information received. So if you see the exact reasoning that you're getting, it's from my system prompt. So in the system prompt, I clearly mentioned if the question is not from the provided context, say, I don't know, not enough information received. So this is what I need to generate if it is not from the context. And this means our RAG pipeline is working fine. And I can also trace it on Opik. I will just refresh this. And if I click on this black hole, again, you can see you have all the nodes. Hardly it's taking just 1 second, 0.7 seconds for LLM to generate the response. And you also have the output tokens. And yeah, this is mainly for answer relevance and context relevance. You can ask as much of user query that you need. If you see context relevance, it is false. Answer relevance is also false. All right. So this is the second user prompt. Then I have third user prompt, which is what currency is accepted. Again, this is from the context. Here I should get true and true. So if you see, I have true. Okay. So now what we have done is we have defined our entire RAG pipeline using Qdrant miniCOIL hybrid search and then LangGraph for our entire RAG pipeline. Now we generated context relevance and answer relevance, which is mainly focused on LLM evals, and you can directly track it using Opik. So if you see here, you have Opik, which is acting as a callback. But what if I have a function which is using LLM? How do I track it? So Opik also provides that feature. So here what I will do is I will define evals, that is precision from ragas, and I want to track it using Opik using a tracker. So you just have to define a decorator called track. So I'll show you how to do that as well. So here what we are trying to do now is we are using Ragas library, which is popularly used for LLM and RAG evals. So here the metrics that I'm utilizing is LLM context precision without reference. So there are two things that you can do. When you are generating evals, do you have a reference? Let's suppose have what is Blackwell. I have the LLM response. Do you also have a ground truth? So in most of the cases, if you have your own data, you don't have the ground truth. So this is the reason why I'm using LLM context precision without reference. And if you have reference, if you have ground truth, then you can use reference. So here is the documentation. If I just come back, core concept, available metrics, retrieval augmented generation, then you have context precision. And here if you see, you have LLM context precision without reference. You also have with reference, where you are giving the reference. For example, where is Eiffel Tower located? This is the reference that you can define, and then the relevant context. But in our case, there is no reference, right? So I just have to remove this ground truth. All right. And now, if you want to define the LLM, since we are using entire LangChain framework, what I have to do is whatever LLM I have defined earlier, let me scroll back. Okay, where did we define the LLM? Okay, so this is the LLM. If you see this LLM component, we have defined from LangChain. And if you want to use any other LLM from LangChain, and if you want to use it within the Ragas, you can do that as well. So you can have one LLM for RAG pipeline. You can have another LLM for your evals, which is a very good LLM, right? If you want to use open source LLMs, even that is fine. You can just define Hugging Face as your LLM and then use it for tracking. So that way, your entire pipeline is completely local and you're not sending any data to your LLM providers. Okay, so here I'm using the same LLM. I'll just use the same LLM, which is Gemini, and LLM wrapper, which is again from Ragas, and singleton sample is nothing but I just want to use one prompt at a time and then use the evals. If you have the entire data set, you can generate the entire data set at once. So if you want to do that, click on evaluation, then you have evaluation sample. Let me show you where that is. So there is something related to evals. Okay, so if you see, you have from Ragas import evaluation dataset, which is from Hugging Face. And once you have this eval dataset, you can run the entire dataset at once using Ragas eval. But in our case, we just have one user question at a time. That's the reason why I'm using singleton sample. So just run this once. And now I'm using context precision, which is the parameter that I've used in my slides as well. So here I'm defining the precision now. And in order to define this precision, the first thing is I need to get the evaluator LLM, which is again the LangChain wrapper, pass the LLM, which is nothing but Gemini 2.5 flash. And then once you have the LLM that you want to define, again, as I mentioned, you can use any LLM of your choice, whether it is open source, closed source. If it is integrated with LangChain, you can define that using Ragas. there are many people who still don't know how to use ragas with open source LLMs. So just use LangChain wrapper, define that LLM from LangChain. And if you don't know how to use open source LLMs, the first video, if you see here, RAG using open source LLMs, here I defined Hugging Face. You can just get that component and you can attach it here, right? You can use open source, you can use closed source. Then define context precision, which is your metric, pass your LLM, and then here you have to define the user input, which is nothing but response question. Let me print this response. So if you look at this response, you have question, you have context, and if you scroll down, you have answer, you have context relevance, you have answer relevance, right? So I'm just passing that response. From that response, I have to extract question, I want to extract answer, and for the retrieve context, what I need to do is just get all the string. So if you see, for doc in response context, so let me get this out. This is nothing but a document. If I just print doc, I only have to extract page content, which is a string. So if you see, I just need this string. So this is what I'm doing here. Get the context, which is a string, pass it inside retrieve context within the list, and use something called a singleton EA score. So this will give you a score, which will tell whether if it is close to 1, that means it's relevant to context. If it is close to 0, that means it is not relevant to the context. And I'll just run precision. And here, if I run await precision, it is 0.999. Now, one question is this tracked? If I refresh this, it is not tracked, right? So whatever 3 questions I've asked, it is already been mentioned here. So if you see, you have response 1. This is response 1, which is what happens when I receive an order. What happens when I receive the order? Then you have response 2, which is what is black hole. What is black hole? And then you have something called as what currency is accepted. What currency is accepted? But here, if you notice, I'm using an LLM. I'm using an LLM. I want to track this. This is the reason why I was using Opik. I'll show you how to do that. So I'll just run it for all the precision. So here response 2 was related to what is black hole. I got 0.0 point 0. And my response 3 was from the context. I got 0.99. Now it comes to the final part. This is the last code. After this, we can take questions and we can wind up. Last part of the live session, where I want to track the custom function which uses LLM by Opik. And here you can use a decorator called track. Okay, so let's again import from Raga's embeddings, import LangChain embeddings. And here the metrics that I'm utilizing is response relevance. You can use anything that you need, whatever you want to track. If it is using LLM, you can track it. Define this. And here, if you notice now, I'm defining track, and it's the same thing. I'm defining the evaluator LLM, then I have evaluator embeddings, then I have extracting the context. I'm defining a single turn sample where I'm giving user input, response, and retrieve context. This is the same thing that I've done. User input, response, then retrieve context. So same input variables, and then just use a scorer. Here, if you see, I'm defining response relevance. I'm giving the LLM, and I'm also giving the embedding model. And then you have a function called singleton A score. A is nothing but run asynchronously. If you see, I'm defining async, and this A is nothing but asynchronous. Add your eval. This eval is nothing but singleton sample. And if you print this course, it is nothing but a float point. It's a float. And then you just have to define this function called Opik context update current trace. One is track and one more is Opik uh, update current trace, where you have to define a name. It can be any username, then value, which is the eval score, and then the reason. Reason can be either a critic or it can be the user response. And just run this. And now if I run this cell, and if I come back to Opik and if I refresh, okay, let me refresh. if you see, you have a new parameter called get context relevance. Sorry, get response relevance, which is already defined here. Get response relevance. Now, if I click on this, you have the question, and if you click on feedback scores, you also have the response and you also have the scores. So this way, if I come back to my initial slide, I said use LLM as a judge, then define trace and monitor, helps to fix obvious errors. So this way, what you can do is ask as much as user query that you are getting, track it using these scores, and wherever you see these scores are not making sense, look at the question, look at the response and fix it. It can be in terms of search, it can be fixed in terms of prompt, it can be anything, right? So this way you can trace, you can monitor, you can also evaluate your RAG pipeline. We covered context relevance, answer relevance, then precision, and also response relevance. And this is it. If anyone has any questions, we can take that and we can probably wind it up. And you have the collab notebook as well. I already shared it with you. Let me reshare it again. And if you just look at the YouTube video that this is the live session. After this live session as well, you can watch it anytime. I'll just pause it. If you notice the description, you already have how to get your Opik API key. And I will also attach my collab notebook so that you can reuse it any single time. And if in case you get any error or if you have any doubts, you also have Discord URL. Join the Discord server, ask any questions that you need. I'll help you out in answering it. So yeah, do we have any questions? Okay, so when should we use Qdrant upsert and Qdrant add document? Okay, so if you are directly using Qdrant payload, right? Let's suppose. So this is the article that I've written. It's the same thing. Here I'm defining miniCOIL, and instead of using Qdrant, okay. So here, if you notice, instead of defining my entire collection name on LangChain instead of Qdrant, what you can do is this entire pipeline, which is point struct. If you are using point struct, then you can directly use upsert, which is directly integrated from your Qdrant client. But if you are using LangChain, that is where you will use Qdrant add document. So add document is an object of LangChain. Upsert is an object of Qdrant client. So this is where you can use upsert. When you are defining your entire collection name and you are saving it in a payload separately directly from Qdrant client, that is where you can use upsert. If not, if you're using your entire pipeline just by LangChain, then you can use add document. I hope that made sense. So upsert is for direct Quadrant client, add document is directly for LangChain. Can you suggest some ways to apply RAG on real-time data where the data from MCP server? So here what you can do is MCP server will act as a tool. So instead of search, what you have to do is whatever node you have, right? So this node will be a function call. So instead of search, you can just keep it as def knowledge. So you can just define it as def knowledge. So you have a user query, and inside this you can define your MCP server. So your MCP server will act as a tool which will get the user query and then generate the response, right? So mainly this will be asynchronous. So if you're defining your asynchronous, your entire pipeline will be async. You just have to use async and await. But yeah, you can define that within a new function, and there you can define MCP server as a tool instead of a different framework. Or do we have any other questions? And if you want to know how to use MCP as a tool, this video is very helpful. Sorry, let me open view channel. And if you look at this videos, I have something called as build your MCP agent. So in build your MCP agent, I'm using Agno, and in that Agno, I'm defining MCP as a tool where I'm using Airbnb. So I ask any question related to Airbnb server, I'm getting the listing. That listing, I can get it as a string and pass it to the LLM. So that logic you can define inside a function if you're using LangGraph. So LangGraph also have MCP server as a tool. You can utilize that. Okay, since we are already up with the time, if you have any more questions, let me attach the Discord server URL as well. So this is the Discord server. If in case you have any more questions, you can join. There is one question. For the last part, Ragas eval is to eval the retriever performance, but why do we need to provide response and answer in the code? Okay, so here, right, for the Ragas eval, the metrics that I've used is LLM context precision. So there are two things that you can use from Ragas dot metrics. I can import precision. So this is one metric from Ragas, import metrics, import LLM context without reference. So this context without reference requires what you call it requires response and it requires a retrieved context. But if you are directly utilizing precision, which is this metrics, then you don't need what you call the response. You can directly pass the question. You can directly pass the context. So if I show you that documentation. Okay, I'm not sure where they have removed, but if you notice this metrics, if you're utilizing it is for the retriever. Since I'm using LLM context based, because I wanted to show you how to track it, because I'm using LLM to track it, and that's the reason why I had to use LLM context, but you can use precision, which will not require any LLM response. You can just use context and question. So this is what you call as precision at K. So what we are trying to do is you have the question, you're calculating precision at 1, which is k equals to 1. Then you will see the precision at 2, which is precision, this k is nothing but for the second k. Same thing you can try for precision 3 and precision 4. So if your precision 1 is 0.99, that means whatever question you have, that question belongs from the context 1. And if it is again 0.7, that means some part of this context as the question. And if it is 0, that means this question doesn't have any context in your third chunk. Same, this will be 0. So in most of the cases, whatever lower chunks you have, right, it will be 0 0. But whatever your starting chunks will be there, right, there your precision will be very high, so that you can directly define using precision. And the matrix is precision at k, where precision at each chunk, which is nothing but context. And if in case you're not able to implement this, you can let me know. I do have the code for that as well. Let me check if I did implement it here. Okay, so what I'll do is here, however, I have to release this blog article that is optimize the prompts via DS5. So for this blog article, maybe I will just include how to use. Okay, let me just add this text. For the DS5 blog, what I will do is I will just include how to use precision at K and recall at K using Ragas with an open source LLM. So yeah, so this will be my aim for the next blog article. And since I've already released two blog articles, the third one will be related to DS5, and I'll make sure I include these two parameters. Yeah, thanks, Dylon, for pointing this out. I'll make sure I'll include this in the upcoming blog. Do we have any other questions, or we are good to go? Make sure to follow the Medium blog articles, because as of now we are at just two blog articles. I'll be releasing four. Two is already done. Two I'll be sharing now, and we also have few videos coming up. So if you see, customer service chatbot is done, then routing agent is done, and all this happened in the last 2 weeks itself. And I'll be pretty active now. I've been following for a very long time, but I've not been consistent enough. But let's just hope I'll be consistent in the coming days. Until then, thank you. Do join the Discord server so that we can stay in touch. Thank you guys for joining.